Okay, continuing from our last discussion about decomposition reactions, today we shall take a look about decomposition by electricity. And as you well know, this decomposition by electricity is called electrolysis. To understand this, we shall take a look at an example. Suppose we have a beaker like thing like this. This will probably look much like a beaker, and also we have two test tubes. So this is one test tube and this is the other one. And suppose we have two electrodes inside these test tubes. And these electrodes are connected to, say, two terminals of a cell or a battery. So here we have a battery. Suppose this is the positive terminal and this one is the negative terminal. So this makes this one, which is connected to the positive terminal, it makes it the anode, and the other one here, which is connected to the negative terminal, that becomes the cathode. Right. So we have this one is the anode and this one is the cathode. Now we're going to fill up this thing with some water. Right, so some water inside this now, like this, and we are also going to fill up the test tubes with water. Now when we pass electric current into this water, of course we can't pass electric current into pure water because pure water is a bad conductor of electricity, so we have to put some drops of acid into this water so as to make it a good conductor of electricity. And when we do that and we start flowing the electric current, what we see is that some bubbles of gases come out from these electrodes. Even some bubbles of gases start coming out from this electrode also. And gradually the water inside these test tubes, they will come down and some gas will get collected over here. So what is going to happen is some gas is going to get collected over here. Like this. Now the amount of gas that is going to get collected in both the test tubes will not be the same. In one of the test tubes, the amount of gas that will be collected will be twice the volume of the amount of gas collected in the other test tube. So water will be displaced and gas will be collected over here. Similarly, water will be displaced and gas will be collected over here. The volume of gas here will be twice the volume of gas over here. Now this is electrolysis of water. What is happening is water is breaking down into its constituent elements, that is hydrogen and oxygen. Okay, and we shall take a look at this in a live experiment. Right, so you can see this is a live experiment showing electrolysis of water. In this you can easily see the bubbles of gases that are coming out from both the electrodes. Right here you may not be able to differentiate between which one is the cathode and which one is the anode, but gradually as you take a look at the top of this experimental setup, you take a look at the top of these test tubes. Gradually you can see these bubbles coming up, and when you take a look at the top, you can see that here the amount of gas collected is twice the amount of gas collected over here. So this must be hydrogen and this must be oxygen, and so hydrogen is collected at the cathode and oxygen is collected at the anode. Anode means which is connected to the positive terminal, and cathode is which is connected to the negative terminal. Okay, so get back here. So here we see that hydrogen is getting collected over here. So we have hydrogen over here. Hydrogen. And oxygen is getting collected over here. So oxygen at the anode and hydrogen at the cathode. The amount of hydrogen gas will be twice the amount of oxygen gas. So the reaction that is taking place can be represented by a chemical equation in this manner. We had 2H2O, and that has decomposed into 2H2 plus O2. Okay, so this is a balanced chemical equation. Now you can see why the amount of hydrogen gas collected is twice the amount of oxygen gas collected. For every molecule of oxygen, we have 2 molecules of hydrogen. So in this video, we have seen the decomposition of water with the help of electricity, and such a kind of decomposition is called electrolysis. We shall be back in another video where we shall be looking at the third type of decomposition reaction. Thank you.